This video here is just going to show you how the oscilloscope works in a few easy steps. So all I have is an oscilloscope with a probe on this side, and what you can also see is I have on the left hand side I have a DC power supply, and I'm going to use this DC power supply to just supply with me with something to measure. Before we go into too much of the detail, let me just say on the DC power supply I have a positive and a negative pole, a plus and a minus. The colors may vary on your setup. I'm not connecting to ground. This ground is connected to the earth of the device, that's connected to the building earth. I'm using positive and negative to connect onto my probe. So if you look at the probe has two connection points as well. This one, which is the negative of the measurement, which is also connected, strangely enough, to earth of the device. And then you have the positive side, which is this side, and you can see when I touch it on the screen it does funny stuff. I'll explain to you a bit later what's going on there. But in essence what you have is two measuring sides, and the oscilloscope is going to measure a voltage for you. So I'm just connecting the negative of the supply to the earth of my probe, or the negative of the probe, and I'm connecting the positive, and you can see it's 1.8 volts there, connecting that here. So it's a DC supply, and I'm expecting to see a DC voltage on this side. Now if you look at the scope, I'm just going to try to zoom in here quickly. If you look at the scope, it has controls on this side here, and these controls are for channel 1 and channel 2, and then for the time. Let me just kill this autofocus as well. So you can see there's a times per division, voltage per division, voltage per division for channel 1 and channel 2. So to display a channel, to activate the channel, what you need to do is you need to press the channel button. So if I zoom out again, if I want to activate or deactivate channel 1, what I need to do is I press this button twice. So channel 1's gone now. To activate it, I press it, and there it goes. To activate channel 2, I press that, and there you can see channel 2's just popped up. And what I can also activate is a mathematical function of the two, which will do something. In this instance, we're adding. That red line is the addition of channel 1 and channel 2. Now you might want to know why on earth are they not on the same level, and the reason is just because they're not set to the same 0. So let's just kill those first, and math as well. So we're sat here with one channel. Now what you need to understand about the oscilloscope first of all is it has a horizontal axis and a vertical axis. The horizontal axis relates to time, and if you look at the definition of time here, you can see that. No, it's not that. Yes, it is, sorry. That there tells you each block is 15 milliseconds. I hope you can see that. That tells you for each block horizontally, you're looking at 50 milliseconds of data, of sample. And then on the vertical axis, it's really just measuring voltage. So it's measuring amplitude in terms of voltage there. So if you wanted to zoom in terms of a tablet, if you want to do that, if you want to zoom in or zoom out of your oscilloscope, you use this button here. And that, you can see, changes that value there. So we're measuring 1.9 volts more or less, we're measuring on the system, which I guess makes sense then to say let's make 1 block per division. So if you were to choose 1 volt per division, you can see that's 1 and almost 2 volts. I'm just going to quickly show you the DC supply again. So if I change this to 1 volt, what you can see is it's now 1 block here, and if I change the voltage per division, if I just say I want each block to be half a volt, then you can see there it's 2 blocks again. Alright, so you can control the zooming level of that. If you wanted to zoom in terms of time, so that's the equivalent of doing that, pinching and extending the time there, what you need to do is you need to change this times per division setting here. So that does exactly the same. That just says I want to zoom in terms of time. So if I just move back slightly here, if I turn this knob, you should see that this tells you now each block is now 1 millisecond. If I turn it to the left, each block is 100 milliseconds. So you can zoom in and out. If I go to each block is 1 second, you can see that it takes about a second to cross one block. It's 1 second, 2 seconds, 3 seconds. So this thing is really sampling quite slow now. So I'm just going to make it a bit faster again. Okay, so that brings me to what X and Y axis means, what they mean. What I also want you to understand, and many people struggle with this, when you set up the scope, you might get no reading at all. We're measuring a DC voltage here, and you can see there's something here on the menu. I'm just going to go to channel 1's menu again. Something here called coupling. What that coupling does is it tells you whether the scope is supposed to filter out DC or whether it's supposed to maintain the DC, to show it to you. So if that there means DC, many of the scopes will say DC or AC or ground. That there means DC. If I press it, I'm coupling on AC now. I'm just going to move away so you can see. So you can see that's a little wave. That means it's coupling to DC. So even though I'm measuring a DC voltage of 1 volt, it's giving me an output of 0. And the reason for this is that AC coupling is removing the DC component of your signal. So that's if you wanted to measure transients on DC signal. If you wanted to measure AC components of something that also has a DC component, you can use this coupling to do that. You can also set the bandwidth. So if you wanted to bandwidth it, or if your probe is not a times 10 probe, see, I don't know if you can see that, but this probe is a times 10 probe. It says there X10. No, you can't see that. There we go. Times 10. So you can also set the amplification factor of the probe just to correct if it's something different. So just go back to coupling. That coupling says just connect to ground, so it's going to give you absolute 0. And while I'm coupling to ground, I can show you that by tuning this knob here, I can move up and down the 0. So this tells me that the 0 volts for channel 1 is now there. So that's just, if I go back to coupling DC, and I'm going to just make this, I've got invert on, I'm just turning invert off. What you can see there is, by changing this, I'm just changing the offset really. It doesn't change the signal, doesn't change the input signal, it just displays the output on a different level. It just moves your ground of your display. That's all that it does. So you can do the same with channel 1 and with channel 2 without any issues. What I also want to show you is what happens if you don't connect the grounds properly. So if I remove the ground of the scope here, you can see this thing is going nuts. Now let's just try to see what is going on. I'm just making my voltage per divisions, bringing it down. You can see there, it's telling me that I have, in terms of a 50 volts per division setting, I have almost 100 volts positive and 100 volts negative signal in here. And that is because I didn't connect the ground. So in essence, my measurement is floating. My measurement is not an accurate one. I'm only measuring one part of it. And now if you were to analyze the signal, you will find that it has an AC frequency of 50 Hertz. So what you're picking up here is really the mains of your power supply. So that's something to be careful with when you're working with scopes. The ground of your scope, that if I point there, that negative terminal of your BNC connector, that is connected to the earth of your power. So if I can just try to grab a plug here quickly, I hope I can get one. Yeah, here we go. So in terms of your AC supply, that there is connected to this here. It's the earth of the building, of the supply. All right. However, if you go back to the power supply, your power supply is disconnected. It's what we call isolated. So for your power supply, I'm just going to focus again. For your power supply, you should see there's a positive, a negative, and also an earth. And that there is connected to the earth of the plug. What's the effect of this? Well, the effect of this is as soon as you connect something on to that probe here, as soon as you connect something onto the negative terminal of your probe, you're in essence earthing it. So you just should be careful when you do that. I've had many students blow up devices because of this. They don't consider the fact that you need to have a common ground and that your scope is earthed. One way to undo that or to improve it is if you look at your plug. If it's a screw plug, if it's an openable plug, you can just connect the earth wire, which means that that earth there is floating yet again. So then you don't have the issue. Another way of addressing that is to say, let's use both channels, let's connect the two grounds of the two channels, and then measure the two separate inputs using two probes, and then use the mathematical function to determine what the voltage difference is. If you didn't get that, it's not too important, don't worry. Okay, so the other thing I want to show you is just quickly how the trigger menu works. So I'm just going to change this over to have a bit of a smaller signal. Alright, if you look at that, it seems fairly small signal. You can see it looks almost zero. If I now zoom into it, you can see there is actually also that little wavy signal that we saw earlier. So I don't know if you can see that now, but I'm down to 20 millivolts per division. If I touch it, it goes haywire. Just again because what you're sampling is floating. You're not measuring anything at this stage. So if you were to just think how I'm going to do this, if you wanted to capture that, if you wanted to have it stationary and look at it properly, one way to do it, sorry, I'm actually going to go back to this one just because it's easier to sample, and I'm going to go back to 50 volts per division. Let's say we wanted to analyze the signal now. We wanted to look at it properly. What you could do is you could use what we call the trigger menu. So you can see on the right hand side here, there's something called trigger. I'm just going to move this a bit. So if you look at the trigger menu, you can see there's various options here. The one option is what type of trigger do you have, and what we want to look for is an edge trigger. We want to look for a falling or a rising edge. So we choose edge. You select which channel you want to trigger on. Do you want to trigger on channel 1, channel 2, or external? And then you shouldn't really worry about this, but let's quickly look at that as well. Do you want to trigger on the rising edge, or do you want to trigger on the falling edge? That's what you select there on slope. Again, you have this coupling option. I'm just going to keep that at DC. And then you can also have a noise rejection, and you can go back here. So we've selected a rising edge. So we want to trigger on a rising edge, and that becomes important in a few seconds. And what we also want to do is we want to set the mode. Now there are three modes that you can select. You can either select auto, which means scope, I don't really want control of this, I just want you to show me stuff and take a good stab at what you're showing me. So trigger using some form of intelligence. You can also choose normal. Normal says just show to me what you have when you have triggered. So synchronize it with the trigger level, and I'll show you how to set that now, and with what you can see there, there's a small arrow. Synchronize it to that in terms of time, and then synchronize it, or at least use my trigger as the synchronizing point. So I'm just gonna, I've changed here now, I've increased the trigger level. The trigger level is saying, where do you want this thing to trigger at? At what level do you want it to trigger? So I've moved it outside of the signal, and if I go back to auto now, you still see it. If I go to normal, you can see the trigger level is there, and it doesn't trigger. So if I now reduce the trigger, I'm just going to increase it first to show you something. You can see here, the scope, you can't see that. The scope is showing me what the trigger level is. I'm just going to zoom out a bit. There we go. The scope is showing me what the trigger level is here. It's 169 volts. I'm dropping it slowly, dropping it, and it should trigger any second now. I'm hoping. There we go, it triggered now. So it triggered on the, as we said, we triggered on the on some kind of a rising edge, as you can see there, and now you can see it's nice and synchronized. And now we can zoom into it. Just going to make it a bit bigger. It's too big. So 50 volts per division, and I can zoom into it in terms of time as well. And what I can do now, and this is really quite powerful, what I can do now is I can use the cursors. I've pressed the cursor button here, and I can now say I want you to measure the I've pressed cursor, and now I can move around cursor 1 and cursor 2 to measure certain time. So this is telling me the difference between cursor 1 and cursor 2 is in fact, let me just get it proper here. So I'm making my 0, setting the signal to 0, and then measuring from, let's go through the crossing. That's the first time it crosses 0, and then I'm going to set cursor 2 to the first time it crosses 0 again. So what you should be able to see, I've just changed this here. I've just measured. There we go. It's crossing 0 there. So the difference between the two cursors is 20 milliseconds. And I'll quickly zoom in just to show you that. Is 20 milliseconds. And you can see that means it's 50 hertz. It's a 50 hertz signal. So that should, sorry about that. That you should remember from somewhere in electronics or somewhere that you've learned. That is the 50 hertz signal that you have from mains. So that's all that is. So what I'm going to also show you is, let's just connect the earths up together again. So I'm connecting the negative of the power supply to the negative terminal, which is connected to earth, the negative terminal of my probe. When I do that, and I'm going to go to the trigger menu again, just to say auto trigger please, and I'm going to kill the measure and the cursors, I mean. There we go, cursors are gone. So what you can see now is that's my channel 1. It's measuring 0, or it looks like 0. When I zoom in a bit, you can see that it's actually a 1 volt signal, which is what we're outputting from our power supply. There we go. So what I'm going to do now is I'm going to try to trigger a certain event on the power supply. I'm going to trigger on the scope. So let's say we go down to 15 millivolts per division. So we have 2 blocks here, and I'm going to try to trigger when this thing falls below a certain level. So I'm choosing trigger menu. Oh, sorry about that. Choosing trigger menu. I'm choosing an edge. Channel 1 is my source, and I want to capture a falling edge. Previous menu, and I want to do it using normal mode. So what you should see now is there's nothing going on. I know that my signal is hovering above there, and I want it to trigger somewhere in between when it falls below it. So let's just use my trigger level. If you miss your trigger level, if you've lost it, you can see there's a small little yellow thing there that just tells you you are way above the trigger level. So it might take ages to find it. One easy way to do it is to just zoom out again so you can see it, and then 0 it. There we go, it's triggering more or less on 0 now, and then you can zoom back out again. Where were we at? I'm just going to make the trigger auto again so that I can see where I am. I think we were at 500 millivolts per division. There we go. So now I can set my trigger level, and I want to trigger at, let's say, 0.5 volt. So when this signal goes through 0.5 volt, I want it to trigger. You can see that's there, 500 millivolts. I'm going to trigger this thing at. I'm selecting, just to show you quickly, it's currently saying auto. You can't see it, it's saturated, but I'm selecting normal now, and the signal goes away. Just going to make this there. normal, and now I expect this thing to trigger as soon as I make my signal drop below 0.5 volts. I'm just going to show you, as I drop the signal below 0.5 volts, I should have a trigger. There we go, it's just triggered here. Can you see that? Right, so if I just take it up again, and I'm going to make my times per division, I'm going to change it to, let's say, 1 second, just so that it's nice and slow. We can all see what's going on. So I'm at 1 volt now. This thing is again waiting for the next trigger, reducing it, and boom, it should have reduced. Now I just need to wait for this whole thing to scan through. You can see it has triggered. I believe it has triggered. There we go. So it just took some time to display because each block took 1 second to do. So what I can also now do is, I know I'm at 0.4 volts, 400 millivolts. I can say, I want to now trigger, let's set the level at 1 volt, trigger at 1 volt, and I want to trigger a rising edge, trigger on a rising edge. So if I, and I'm just going to make this 500 milliseconds, just so it's a bit easier to, or quicker to respond to the change. Now I can up this, and as soon as it goes through 1 volts, it'll trigger. You can see it's triggered, and it's just finishing its sampling. There we go. That's how the signal progressed. And that's the 0 of the trigger. So it also stored the preceding 5 blocks, which is 2.5 seconds. So 2.5 seconds before it triggered, it also sampled, because I've set my trigger time in the middle. You can change that using that button there. But it makes sense to have it at 0. So you can see what happened preceding and after. The only other thing I want to show you is that you can do, instead of normal triggers, you can also do once-off triggers. So typically you do this when you have multiple events, you're expecting multiple triggers, and you only want to capture the first one. So at mode, it's normal, but what you say then is you press the button single. So scopes differ in the way they do this. I'm just going to take this, my voltage down to something low again, 0.5, and now it should trigger when I go through 1 volt, and it should trigger it and display it here again. But if I go down and up again, it won't trigger again because I've selected single, and you can see it's pressed stop there. If I want to just trigger one more time, I can press the run button, and that'll allow it to trigger once more. I hope that makes sense. That made sense. Let me know if